Hey guys, welcome back to NCERT Class 12. We on diet problem. So this is exercise 12.2 and question 2. I decided to set up my round question, and the reason that you'll find in the video. So watch carefully and let's figure out whether you can do it by your own. So that's actually lots of details, so keep watching. The question: there are two kinds of pies. One pie requires 150 grams of flour and 30 grams of butter. And there is another kind of pie requires 120 grams of flour and 50 grams of butter. So you need to find a maximum number of pies which can be produced from 4.2 kg of flour. Okay, and 1.2 kg of butter, assuming that there is no shortage of any ingredients mentioned, so no shortage of flour and butter. Okay, so there are actually several details in this problem, so I decided to have shortcuts, so I prepared my solution. So pause the video, try to do by round, and let's go to solution clarified. Okay, so the way you can solve this problem, let's have a look. First of all, we need to set up the table, two-way table for two types of pies and for ingredients. So we've got butter and flour, so I split them up as well, and we have two kind of pies. Okay, so how you set up, I just show you the direction of how you can set up it quickly. So one pie requires 150 grams of flour and 30 grams of butter. So you start writing for pie 1, basically a recipe, 150 grams per unit and 30 grams of butter per unit. Okay, so you just fill in that direction. So first you goes down, so you found the product, and this is pie 1 in this case, and you start filling up the rows. Okay, that's for ingredients. For pie 2, you go next. For pie 2, it requires 120 grams of flour according to that, and also 50 grams of butter. So that's why you just fill in. Okay, so the total actually resources available. You see the difference. First of all, let's pay attention to the units. Grams versus kgs, so kilograms in this case. Find a maximum number of pies which can be produced for 4.2 kg of flour. That's the limit of ingredients that we have at stocks and inventories. It doesn't matter where. So actually we have those resource available at maximum. So that's why that's the maximum resource we have on hands. So what about 1.2 kg of butter? Again, that's resource that we have at maximum. Okay, that's the first. So that was step number 1. We filled out the table. Okay, then we need to set up constraints as well as our objective function. So I would like to start from objective function because that's the primary goal, and I'll set up it here. So what about z, how it looks like? Before doing that, of course, we need to input x and y variables. So the hint is in the question. You need to find the maximum number of pies which can be produced. So you're looking for maximum number of pies. So first of all, pay attention to maximum number of pies. Pies is measured in pieces, right? So each pie is just 1 unit. So what can you say about x and y? If we set up for pie 1, we set up x variable, and for pie 2, we're going to set up y variable. So what can you say about variable constraints? So first of all, they're not going to be negative, right? But on top of that, they're going to be whole numbers or integers. Okay, so that's why we immediately set up the function z. In this case, we're not sad about any consumption as it was before, so we just set up x plus y. That's the total output. Okay, our objective function is going to be output in this case. So output measured in units. Okay, that's basically pieces or units. All right, that's our objective function. So first of all, we set up constraints, non-negative, for x and y. And also we need to mention that they're integers, okay? Integers. It means that there cannot be decimals, only integers or whole numbers, okay? That will be crucial for your solution in this case. And actually in your actual problem that you have in your books and where you can get solution in the description below, actually you don't have this problem. So, but I intentionally trying to clarify those details because in this case, we'll see actually, but it seems to me that in this case, you'll get a maximum function when the numbers x and y are decimals, okay? And that's why we need to resolve this problem, okay? So let's go about inequalities in this case. What about consumption? So we've got flour, 150 grams per pi 1 and 120 grams per pi 2. So that's why if we have x and y together, let's consider consumption of flour as, so for flour, we have 150x, that's the total consumption of flour per x units of pi 1. On top of that, we've got 120y, that's consumption for pi 2. And those resources that we have on hand is going to be 4,200. So that's why we set up less or equal than 4,200, okay? So one more time and just, okay, 200. That's the first inequality that we have. Okay, so probably we need to, oops, that's again the problem with the software. Okay, anyway, I'm not gonna touch. So what about butter? So what about butter? So for butter, we can set up the same consumptions using 30 grams and 50 grams. So we have the following 50, oops, 30 first goes. So 30x plus 50y is going to be less or equal than 1,200, okay, in total. So you see that first we convert every single unit of weight, or actually mass, right, into grams. That makes more sense because you cannot cope with different units. So otherwise you need to come to single units of measurements. Okay, so we set up two inequalities and also non-negative constraints for x and y. Okay, so you can simplify, of course. You can come up, like, you can divide first by 10, you can cancel everything by 10 and reset up inequality. So I hope you can do by your own, but guys, I want to save my time, so I want to show you all the details that actually really that you need to be concerned about, okay? So what I'm going to say, we set up the butter curve, the butter straight line. We set up the flour straight line, which is red, and for butter is like dark blue. And we set up the region because in this case y is going to be less than those equations of the lines. We can say that our region is here, okay? So that's our region between the vertices 24, those decimal vertex, and 28 that I mentioned here, and also 0. So we have basically bounded region. So we have bounded region, and that's cool. It means that we are not going to estimate further inequality for half of the plane that we have for objective functions. So that means if we found maximum, because in our case we need to find the maximum number of pi's that we can produce. So actually we're looking for maximum value through calculating z in vertices. All right, so we've got 0, 0, that's the first vertex. It's right there. I mark with red as well. So we've got this, and obviously it's minimum value. So next vertex, O24. So Y24 is there. we also calculate and we've got 24. That doesn't work because we have even more. So when we take 28, it's right there. We've got 28 for z. And now it's time for decimals, okay? When we plug coordinates of that vertex, we've got the maximum value. So right now, this is the maximum, okay? However, the problem is 30.77, and in terms of values for x and y, we have fractional numbers. So in that case, we have both x and y fractional. So what it means, fractions. So what it means, we need to redo that in terms of what we're going to say. We're going to say that we need actually to test our z function so that it's going to be integers. So the closest integer that we have is that point, okay? So the coordinates, let's set up as v1. That's the nearest point to actually within that lays within the region, and coordinates of which represent integers. Okay, so if as I set up actually the coordinates for that, for v1, I put the coordinates, it's going to be 18 for x and 12 for y. If I plug those coordinates into z, I'll get 30. All right? So that's one possible. Actually, how you can test by your own, so how you can test the nearest integers. You can set up having that decimal value for z, and this is ideal maximum. You can set up an equation of the line when z is equal to the maximum, which is ideal. And you can set up an equation. So x plus y is going to be 30.77. If you drop this line, I already did it. If you drop this line right onto the graph, so I just show you how it looks like, okay? So it will look like it goes through the point of the vertex, and of course it will have the single point. So I'll drop that, but let it be the equation of that line. I drop that on coordinates, on Cartesian plane, and so according to what I see, it goes through, if I set up that correctly, it goes through 30.77. Of course, the value is going to be y-intercept and x-intercept simultaneously. So it's going to be somewhere around 30, very close to. It goes through the vertex and goes again through 30 of that point as well. So let it be, okay, one more time. Oops. Sorry, my bad. I'll try to do one more time. Okay, let it be ideal line that goes through 30.77 and 30.77. Of course, that's going to be intercepts. And that's your ideal line. So you understand that the nearest point to that is actually, as we established, v1. So that's the nearest point for that line. So that we can reestablish equation x plus y equals 30. And if you plug that, you'll have exactly the line that will go not through 30.77 and 30.77 for x and y intercept, but it will go through 30, okay? So the line, this line that is not ideal, but actually it satisfies so that x and y both going to be whole numbers. That line will go through the vertex and 30, 30, okay? So, and this will deliver us x and y solutions as integers. So the first solution is 8 and 12. And the maximum that in this case actually works for a z function is going to be 30. So in total, we have 30 pieces of pies, okay? But however, we will have one more point with combinations, with another combination. If it would take 20 and it would take 10. Oh, how many? Yes, 20 and 10. So there is another point, 20 and 10, that's actually here. That's V2. So it's going to be 20 and 10 combinations. So X works as 20 and Y works as 10. So that's going to be V2, vertex 2. That's vertex, it's not actually the vertex, but that's the point, integer points within the region. So both 2 points are actually integer points within the region. So within region R, okay? So that means they deliver us integer solution, and also in terms of maximum values of output, it will satisfy 30. That's very close to 30 points is 77, okay? So, but that's the actual solution in our case. So guys, those were actually details that you need to take into account when you explore a solution. So when you have on exams similar problems, and that's actually for those who are trying to practice and understand depths. So guys, make sure you investigate those details and make sure you read carefully your question. So question here, number of pies, that means they need to be integers. So that's small, like word actually will have a great influence, okay? Influence on your solutions. So hopefully in your actual question 3, you don't have this. So you have like a whole solution. Let me see, the actual solution for your problem is going to be actually the same like corner point or vertex point there, but it will have integer coordinates. So here I intentionally demonstrate what if the points of intersection of those 2 lines will deliver non-integer points but decimals, okay? Make sure you know what to do in this case. Okay, so that's the solution for our problem. So as you can see, you have 2 combinations that both delivers the same maximum output. Okay, so make sure you actually understood how to do this. So that was diet problem. Here is the full solution for that. So guys, thank you for joining, and you can drop any questions you have. So probably maybe offer what to do next, because so I'm going to consider question number 9 and 10 because they are very interesting and they are different from what we're doing a little bit in terms of how we set up the table, how we set up objective function. However, so it seems to me that's enough for linear programming. So 9 question and 10 question, that's okay. I'll try to create in the nearest, so in a few days, and it seems to me that's enough. So drop in the comments what you expected next. So probably it will be a very interesting topic, maybe about differentiation, so integration, it's up to you guys. What's the next chapter coming to your class? So just notify me about that. And of course, don't forget to share this video to anyone, students who are struggling with NCERT program and who is on chapter 12 right now. That was Daniel Dallas. Peace out.